Hello everyone, I'm Abhinaya from Flipkart. In this video, I'll be presenting our work titled Social Re-Identification Assisted RTO Detection for E-commerce. What is an RTO? Return to origin refers to a scenario where a customer cancels an order after it has shipped from the source location. This results in logistic losses, which is the forward and the reverse supply chain cost, and opportunity losses where between the time this order was placed and cancelled, it became unavailable for another customer who would have actually taken the delivery. Now, these losses at Flipkart scale can cause significant revenue loss, and hence it becomes important to build a system that can predict the likelihood of an order becoming an RTO so that necessary interventions can be taken in order to mitigate this RTO risk. To build such a system, we consider the historical order and RTO data for customers, extract relevant features, and build a model that would result in certain performance data. With social re-identification, we identify their corresponding social profile, extract their social data, derive relevant social features, and our hypothesis is that together with these social features, the performance of our model would improve. The motivation for this comes from the literature where it is shown that the socioeconomic attributes of a person are indicative of his tendency to commit fraud. Here are some of its sample literatures. Moving on to the proposed approach, we'll be discussing the data collection, data validation, and finally the modeling and the results. So for a given Flipkart user, we create a search query combining the name and location of the users and pass it through Google search engine and the social platform search engine in order to retrieve the results. The top 10 results from here are considered our candidate profiles, and the search is further refined in the data validation step. Now, in order to avoid any privacy and platform violations, we only consider the data that is publicly available on the platform for our experiments. And these are also used only for this academic POC purpose. At Flipkart, a user can make their name location public along with the reviews they write for the products. So for our experiments in this project, we only consider the users who are in the intersection of RTO dataset and the publicly available review dataset. With this, we had around 2000 users, of which we could find a possible social match for around 50% of them. And this constituted a data set of around 3600, and this is used in our experiments. This concludes our data collection. Moving on to data validation. We'll be checking the intersection between location of user that is present in the Flipkart profile versus the social profile in order to validate these candidates. That is, given a Flipkart user, we get the set of location for this user from the order history. Similarly, for a candidate profile, we get the set of locations from the social profile. And the match score for this candidate profile is obtained as the fraction of locations in the social profile that are also present in the user's order history. Now, the candidates for which this match score is over a threshold are considered the matches. So for a given user, we could have a single match, multiple match, or no match. Users with no match are removed from our experiments and we only consider the single and multiple matches. Moving on to modeling, we consider three types of features. The first is the features that are internally available at Flipkart, which are mostly the past RTO trends at user, product, category, and other granularities. And then we have quantitative social features, which are extracted from the social profile, and some contextual embedding based features for job and education that are again extracted from the social profile. With this, we have experimented with tree-based ensemble models like Random Forest and XGBoost and attention-based architectures like TabNet. Random Forest was found to perform the best with the internal features giving a recall of around 40%. Adding social quantitative features improved the recall by 10%. Adding the contextual embedding feature improved the recall further by another 10%. Contrary to our intuition, TabNet performed the worst. It's also shown in studies that the performance of neural architecture is not consistent when it comes to tabular data, and these are heavily sensitive to parameter tuning. This concludes the modeling. So in our work, we have shown that using social re-identification can improve the performance of a compelling e-commerce problem like RTO. Thanks a lot for listening.